Good morning friends, welcome back to Panika Tutorials. In this video, I want to discuss one of the gate question which came in the year 2017 related to preemptive priority scheduling algorithm. These kind of questions will help you to understand the concept in a better way. So I request everyone to watch the complete video for better understanding. First let me read out the question, then I will discuss the solution with you. Look at the question. Consider the set of process with arrival time and burst time in milliseconds, and priority 0 is the highest priority. None of the process have IO burst time. They have given 5 process, their priorities, arrival time and burst time. Compute the average waiting time using preemptive priority scheduling algorithm. If you look at the question step by step, look at this one. Consider the set of process with arrival time and burst time in milliseconds. Okay, arrival time they have given 0 milliseconds, 5 milliseconds, 12 milliseconds, like that. And priority is 0 highest priority. 0 is the highest priority. If 0 is the highest priority, then 4 will be the lowest priority. Is it clear? Are you able to understand it or not? None of the process have IO burst time. So no process will go to the wait state. Once it is gone to the running state, if high priority process comes, then it will go to the ready state. So process will go from the ready state to running state. None of the process will go to the wait state. Now we need to compute the average waiting time. So what we need to do, first we need to compute the completion time, turnaround time, waiting time, then only we can compute the average turnaround time. To do all these things, what we need to do, we need to draw the Gantt chart. Look at the scheduling algorithm. They have given preemptive priority scheduling algorithm. Okay, now any scheduling algorithm will have two parameters. One is the criteria and another one is mode. What is the criteria here? Priority. The process which has the highest priority will be dispatched to the running state. And the mode itself, the name itself is saying it is a preemptive scheduling algorithm. Okay, now coming to the Gantt chart, always the Gantt chart will start from 0 units of time. To explain the concept, out of the 7 states in a process state diagram, they are new, ready, running, terminated, wait, suspended wait and suspend ready. I will use the 2 states such as ready and running. Okay, now if you look at the arrival times, at 0 units of time only process P1 has arrived. If process P1 has arrived, that will be dispatched to the running state. Okay, now process P1 needs 11 units of time, but as it is a preemptive, what you need to do, you need to look at the arrival time of other process 5, 12, 2, 9. So process P4 is arriving at 2 units of time, so we can run the process P1 for 2 units of time. So its remaining burst time is 9 units. Are you able to understand? Now at 2 units of time, process P4 has arrived. Now look at the priority. Process P4 has the priority 1 and process P1 has the priority 2. What they told, 0 is the highest priority. The next highest priority is 1, then it is 2. So among P4 and P1, which has the highest priority? P4 has the highest priority. So there is a highest priority process is waiting in the ready state, then the process which is running in the running state, then we have to do the context switching. Okay, so process P1 will be shifted to the ready state and process P4 will be scheduled to the running state, and process P4 needs 10 units of burst time, but you need to look at when the next process will come at 5 units of time. So you can run the process P4 for 3 units of time and it will complete 3 units of time, so its remaining burst time is 7 units. Okay, are you able to understand? Now at 5 units of time, process P2 has arrived, and look at the process P4, P1 and P2, which has the highest priority. Process P2 has the highest priority. Among all the process, P2 has the highest priority. So a highest priority process is waiting in the ready state, then the process which is currently running. So you need to do the context switching. Process P2 will come to the running state and process P4 will be shifted to the ready state. Now process P2 needs 28 units of time. Even it is a preemptive scheduling algorithm. If you look at other process, they have the lowest priority. So P2 will complete its task for 28 units of time. At 33 units of time, process P2 will complete its task and go to the terminated state. By the time process P3, P5 has come to the ready state. Now, if you look at the priority, next highest priority is P4 because after 0, P4 has the priority 1. So, P4 has the highest priority. So, P4 will be scheduled to the running state. Now, P4 remaining burst time is 7 units. Among all the process P1, P3, P5, P4, P4 has the highest priority. Even it is a preemptive. Now compared to the process which are there in the ready state, P1 4 has the highest priority. So it will run for 7 units of time. So at 40 units of time, process P4 has completed the task. Now P1, P3, P5 are there in the ready queue. Then which process we need to send to the running state? It depends on the priority. P1 has the priority 2, P3 3, P5 4. So which has the highest priority? P1. So that will be scheduled to the running state. What is the remaining time of process P1? 9. So it will run for 9 units of time. At 49 units of time, process P1 has completed its task. Then P3, P5 is there. P3 has the highest priority. So it will be scheduled to the running state. And process P3 needs only 2 units of CPU burst time. So it will run for 2 units of time. At 51 units of time, process P3 has completed the task and will go to the terminated state. Only process P5 is there. There is no other process in the ready state. So there is no competition. So process P5 will be scheduled to the running state and it needs 16 units of time. So it will complete the task at 67 units of time. Is it clear? Are you able to understand? Now we'll compute the completion time, turnaround time, waiting time and average waiting time. If you get it doubts, have you done correctly or not, compute the burst time of all the process. Sum 11 plus 28 is 39, 39 plus 2 is 41, 41 plus 10 is 51, 51 plus 16, 67. Yes, at 67 units of time, all the process are completed because there is no CPU idle time. Maybe it is correct. Okay, are you able to understand whether it is correct or wrong? You only have to tell in the comment section. Okay, now we need to look at the completion time of each process. P5 has completed at 67 units of time. P3 has completed at 51 units of time. P1 has completed at 49 units of time. P4 has completed at 40 units of time. P2 has completed at 33 units of time. Now we need to compute the turnaround time. Turnaround time is equal to completion time minus arrival time. Now 49 minus 0 is 49, 33 minus 5, 28, 51 minus 12 is how much? 39. Okay, 40 minus 2 is 38, 67 minus 9 is how much? 58. 58 plus 9 is 67. Okay, this subtraction is a little bit confusing. So 49 minus 0 is 49, 33 minus 5 is 28, 51 minus 12 is 39, 40 minus 2 is 38, 67 minus 9 is 58. Now we will compute the waiting time. Waiting time is equal to turnaround time minus burst time. Okay, so 49 minus 11, 38. Okay, 28 minus 28, 0. 39 minus 2, 37. 38 minus 10, 28. 58 minus 16, which is 42. Are you able to understand? Again, if you want to clarify, you can check it. Turnaround time is 49 minus burst time. 49 minus 11 is 38. 28 minus 28 is 0. 39 minus 2 is 37. 38 minus 10 is 28. 58 minus 16 is 42. 42 plus 16 is 58. Okay, we got the waiting time of all the process. Now we need to compute the average waiting time. Average waiting time is sum of all the process waiting time by number of process, which is 38 plus 37 plus 28 plus 42 plus 0 by 5. Is it clear? So what you will get, 38 plus 37 is how much? 1575. Okay, 75. 48 plus 22 is how much? 70. Okay, by 5, which is how much? 145 by 5. Okay, are you able to understand? It is looking like 29. Yeah, am I right? So the right answer is option A. So for this question, option A is the right answer. If you still have any doubts related to this concept, feel free to ask me in the comment section. I will try to clear your doubts as early as possible. Thank you for watching the complete video. Have a nice day.